2007 relative velocity, ship B, traveling west at 24 kilometers an hour. Ship A, traveling north at 32 kilometers an hour. At a certain distance, ship B is 8 kilometers northeast of ship A. Find the velocity of ship A relative to ship B. Okay, let's look at the velocity of ship B, which they give us first. Velocity of ship B is going to be equal to west at 24 minus 24 in the I direction plus 0 in the J direction. That's my dog snoring, not me in the background. It's the velocity of ship A, north at 32, so 0 in the I direction plus 32 in the J direction. And the velocity of ship A relative to B is the velocity of A minus the velocity of B. So we want here, should probably go both in, that's going to be equal to 0 minus 24, so that's going to give plus 24 in the other direction. And then we're going to have 32 minus 0, so just plus 32. In the J direction, the magnitude of the velocity of A relative to B is the square root of 24 squared plus 32 squared. Both of those are divisible by 8, which would make them 3 and 4, which the answer would be 5. So multiply 5 by your original 8, you get 40. That's the answer here. And the direction, the inverse tan of 32 over 24 is from that same 3, 4, 5 triangle. That will be the inverse tan of 4 over 3. 53.13 degrees. And calculate the length of time here. We're told that at a certain instant ship B is 8 kilometers northeast of ship A. So we have A, ship B, 8 kilometers northeast. It's my 8. Ship A, ship B. And we have the angle, the relative velocity of A relative to B is 53.13, so this is 45 along here. If it's northeast, that's 45. We have, just make it a little bit bigger than 53. This is kind of my wonky straight line. Let me do it again. This is the velocity of A relative to B. Coming up in a positive direction, so the shortest distance will be down there, my right angle, so 8 is my hypotenuse as always. The distance will be my hypotenuse in the question. So the angle inside the triangle this time is going to be this one here, which is 53.13 minus the 45, which is 8.13. So we have this 8 here for the hypotenuse. So we're looking for the length of time to the nearest minute for which the shifts are less than or equal to 8 kilometers apart. So there'd be another line going this way along here. And so we're looking for this x and this x here. That's the length of time to be within 8 kilometer range. So that's the cosine. We're adjacent to this angle. So x is going to be equal to 8 by the cos of the angle. You guys know this already. You've done so many of them. 8 cos 8.13, 7.92 by 2. It's going to give 16 minus 1.16.84. And the relative speed was this 40 we got here, kilometers an hour. So what do we have? We have distance divided by speed, dst, distance over speed is equal to time. Always double check. So the time here that they will be in this interval of 15.84 kilometers will be 23.76 minutes. And we want it to the nearest minute. The time will be 24 minutes.